Good morning, students. Let us discuss about allotropy and catenation capacity. So generally, first off, see the definition. So here allotropy is nothing but what here? Allotropy is nothing but existence. Allotropy is nothing but what here? Existence of an element in two or more physical forms is known as allotropy. Means what here? What is an allotropy? The element whatever you are taking, it will exist as a two or more physical forms. Means different physical forms we are going to have. That one we call it as allotropy. So here in group 6 elements, means the group 16 elements, it will exhibit allotropy. We can say oxygen occurs in two metallic forms. Oxygen occurs in two non-metallic forms, we can say, that is O2 and O3. So oxygen can exist as allotropy as oxygen and O3, where oxygen is a paramagnetic, it contains two unpaired electrons as per molecular orbital diagram. Where coming to ozone is a triatomic allotropic form of oxygen, we can say it is unstable. Why? Because it is decomposing, as we have seen the preparation of ozone. Yes or no? So now let us see about sulphur. Sulphur is have more sulphur has more number of allotropic forms so all these are what here, which is a non-metallic, we can say. Okay, sulphur has more number of allotropic forms, which is a non-metallic forms. So here we are having the sulphur as alpha sulphur, we can say, or rhombic sulphur also, we can say. The first form sulphur existing as alpha sulphur or rhombic sulphur. Coming to here, rhombic sulphur, so this is yellow in color. This is yellow in color, which is having melting point 385.8 Kelvin and specific gravity 2.06. So here the rhombic sulphur crystals is evaporated solution in CS2, we can say here. And coming to here, it is insoluble in water. Insoluble in water and soluble in partially soluble in, we can say, benzene, alcohol, ether and CS2. Okay, so this is nothing but rhombic sulphur, which is also known as alpha sulphur. And next one we are having here beta sulphur, or we can say this is a monoclinic sulphur, or prismatic sulphur. Okay, beta sulphur we can say, monoclinic sulphur we can say, prismatic sulphur we can say. This is a beta sulphur. So it is going to have melting point 392 Kelvin. It is having the melting point here, and the specific gravity is 1.90. It is also soluble in CS2. This form is sulphur, which is prepared by melting rhombic, we can say. Sulphur is a dish and also cooling till crust is liberated. It is a thin also, we can say, and also we are having gamma sulphur. Gamma sulphur, or we can say monoclinic sulphur also. This is also a monoclinic sulphur. And coming to zeta sulphur or plastic sulphur. Okay, so alpha, beta, gamma, these all are crystalline in nature. We can say these three, whatever it is there, these three are crystalline nature and forms puckering structures. Okay, puckering, that is S8. So sulphur can form what here? Sulphur forms S8 structure, which is having boiling point here 180 degrees centigrade. So when you increase temperature, the dissociation of S8 will change into S6, S4 and SO units. Okay, so in cyclic form here, in cyclo, SS is converted into S6, S4, S2. Okay, in cyclo S6 form, what will happen? The ring adopts chair form. The most stable allotropic form of sulphur is, that is rhombic sulphur, we can say. So the chair form, how it will be having like this. The most stable form is this one. Here we are having sulphur, 6 sulphur. So this is nothing but chair form and S8. Puckering form, or we can say this is S6 form, this is S8 form, or we can say crown. Okay, so this is here S8 ring in rhombic sulphur. So this is the structure S8, whatever we have taken, that is a rhombic sulphur. And beta sulphur is also soluble, so which is a both rhombic and which will be in equilibrium. So this one we call it as a 369 Kelvin, both rhombic and monoclinic forms can coexist in equilibrium. This temperature we call it as what here? This temperature is called transition temperature of sulphur. Okay, so this is nothing but allotropy of sulphur and oxygen. Now let us see about here. Let us discuss about catnation capacity. So what is catnation? Catnation itself forms an bonding with elements in ring or chain form. That one we call it as what here? Catenation. So for example here this is one of the catenation and this is one of the catenation. So means what? Itself only it is forming a bonding. That one we call it as in ring type we can form or in chain type. That one we call it as catenation. So coming to here, oxygen and sulphur. Oxygen and sulphur will show catenation capacity. Okay, catenation is maximum in sulphur up to 10 atoms we can say. So it is having, the sulphur is having capacity up to 10 atoms, that is H2SN, where N is equals to 2 to 10 atoms we can say. In case of oxygen it is having only 2 only. That one we call it as catenation capacity. So this is about catenation capacity of sulphur and oxygen. Now let us discuss about sulphur dioxide. Preparation of sulphur dioxide. Okay, so here coming to preparation of sulphur dioxide, first of all it is a direct method we can say, with a little 6 to 8% of sulphur trioxide when sulphur is burnt in air or oxygen. Means what here? S plus O2 gives rise to. So this is a solid, so this is a gas. So whenever you treat, directly we will be getting sulphur dioxide, that is means in the presence of air. The sulphur dioxide is formed whenever the sulphur is burnt in the air. Here we are doing heating procedure. Okay, so in laboratory, so this is about first preparation. Coming to second preparation, in laboratory whenever you are taking sulphite in the presence of acid. Okay, so means what here? Sulphite with dilute sulfuric acid. So you will be getting water molecule and sulphur dioxide. So the gas after drying is liquefied under pressure and stored in steel cylinders. So whenever you are having steel cylinders, it is stored. Okay, and also coming to industrially, how we have to prepare in industrially, this is according to lab we are preparing. This is in the presence of atmosphere, which is occur naturally. So in industrial process we are preparing as 4FeS2 ferric sulfide. Okay, so whenever the ferric sulfide is treated in the presence of oxygen, it will form 2Fe2O3 plus 8SO2. So we need actually sulphur dioxide, that only. So this process we call it as roasting process. Why? Because it is happening, the reaction which is happening in the presence of air, the sulphide ores which is present in the presence of air, we call it as roasting. So here the ferric sulfide is in the presence of air, we are getting ferric trioxide and sulphur dioxide. So these three are the preparations of the sulphur dioxide. Now let us go for properties. So here properties is nothing but what? SO2 is a colorless gas. With pungent smell. With pungent smell and is soluble in water. Okay, so it liquefies. So this gas will get liquid under a pressure of 2 atmosphere and boils at 263 Kelvin. Okay, so this is nothing but physical properties. So here what will happen? The sulphur, it liquefies. The sulphur will liquefies at room temperature under a pressure of 2 atmospheres and boils at 263 Kelvin. Okay, so whenever sulfur dioxide is reacted with water, so we are getting automatically sulfuric acid. So it reacts readily with sodium hydroxide solution to form sodium sulfate, and which then react with again water to form sodium hydrogen sulfide also. So whenever whatever, so here what we are forming, hydrogen sulfate we are getting. Okay, or we can say sulfurous acid. Sulfuric acid is different, sulfurous acid. Sulfuric acid means H2SO4 we are getting. So whenever you treat with 2NaOH, automatically what will happen? 2NaOH plus SO2 gives rise to Na2SO3 plus H2O we are getting. So again this Na2SO3 plus H2O it will give, and also plus SO2 it will give 2NaHSO3. So in this reaction with water and alkalis, what will happen? The behavior of sulfur dioxide is very similar to, means it is similar to carbon dioxide only it is happening. So when you take it as a charcoal which is acting as a catalyst, okay, so it will give sulfuryl chloride, and also it is oxidized to sulfur trioxide in the presence of vanadium, we can say. So if you have taken this is SO2 plus Cl2, it will give SO2 Cl2 sulfuryl chloride. So means what? In the presence of charcoal we are taking. Charcoal is nothing but here carbon powder we are taking. In the similar way, this is a contact process. In the presence of vanadium pentoxide, so you are getting sulfur trioxide. So there will be oxidation process is happening here, and also reduction agent also it will happen. So means what here? This is when you are treating with 2Fe3 plus SO2 plus 2H2O. It will give 2Fe 2 plus SO4 2 minus plus 4H plus. So in the presence of the higher oxidation state is reduced to lower oxidation state. So this is nothing but reducing properties, and also 5SO2 plus 2MnO4 minus plus 2H2O. It will give 5SO4 2 minus 4H plus 2Mn2 plus. So these are the chemical properties. It can undergo oxidation reaction, it can undergo reduction. So these two will be undergoing reduction. So this is nothing but oxidation. So these are undergoing with acids and bases also. Okay, so this is nothing but chemical properties. Now let us see about uses of sulfur dioxide. So sulfur dioxide, generally we are having the sulfur shape is S double bond O. Like this we are having angular shape, we can say. So when you turn lone pair of electron, automatically it will be getting like this O, as we have seen ozone, which is a angular shape, same like so. This is angular shape, we can say. Sulfur is a, so generally where it is used, sulfur is used as a sulfur dioxide is used in refining petroleum and sugar. It can be used and also used in bleaching wool, and silk, we can say. Sulfur dioxide is also used in anti-chlor, disinfectant, and preservative for food. Preservative for food, sulfuric acid, sodium hydrogen sulfide, and calcium hydrogen sulfide, which is manufactured from industrial process, we can say. So these all will be used from sulfur dioxide only it is used, which is manufactured from industrial process. These all compounds whatever we are getting, this is all from manufacture. And also liquid SO2, which will be used as a, means when the gas is liquefied, it is used as a solvent, to dissolve number of organic and inorganic chemicals, we can say. Okay, so these all will be the uses of the sulfur dioxide. So this is nothing but sulfur dioxides, and we are having oxy acids of sulfur also. So oxy acids of sulfur is nothing but it will exhibit different forms, oxy acids of sulfur. So let us discuss about tomorrow oxy acids of sulfur. Thank you.